Welcome to this week. So this week we're going through our tutorial from week 11. So this one here is our drainage layout, calculating our pits sizes and working out our pit cross sections. So I hope you've all read through the notes. Alright, so this week's tutorial is relating to this example here, designing pits 1, 2, 3 and 4. So I hope you're familiar with the calcs. We went through them last week. So just from our tutorial, just need to pull up a bit of information from here. So what we need to look at is our curb and gutter grade. So it's only a 0.5%. All right, we need to know this for when we're getting our RLs for the top of our pits. The other thing you need to, look at from here is obviously we're going to rationalize our pit spacing. So that's given to us in the question here. We're taking 160, 100, 80, 20. We're assuming 150mm concrete pipes. We've got a roughness factor here, 1 meter SEPs with no deflectors, so we can work out our catchment for them. We're assuming a RL of 100 meters for the top of the first pit, taken as the top of curb because we're dealing with a side entry pit. If it was a standard graded inlet pit, we'd be taking the water table level. The other thing we're going to do is assume the hydraulic grade line is 300mm below the water table at the first pit, recommending this being our freeboard or our cover. Okay, remember our hydraulic grade line is the pressure line of our fluid in a pipe. So if we were to not encapsulate that fluid, we'd expect to see it reach this level. By doing this, we're creating a buffer for if something goes wrong, that pit's not going to overflow and spill into our street. Okay, so let's start. So looking at pit 1. Alright, what are we going to begin with? Well, let's start by just reflecting on some of these calcs. So looking at the low side. So these ones here, for the low side, we're only looking at half the road. What we've calculated here is we've got 0.12 litres per second per metre. Alright, the other thing that we've calculated here as well is for my initial pit, I've got 15.2 litres per second. We've got 3.8 litres per second for my bypass. Alright, taking a 1 metre pit. Alright, so we've got to use some of these numbers as well, and we'll be referring to our appendix and how we've calculated these initially. So, pit 1. So pit 1, sorry, let's just come back here, go a bit more further. So pit 1, this is where all the water that runs on this side of the road is going to move into this pit. Some will bypass, 80% will go in, connects to a pipe. That pipe runs to another pit. Alright, so water will flow from this roadway to the top of the pit, plus from this pit in this pipe running through, so on and so forth. Now this pit here does not have a pipe connecting to it. So just to reflect on what we've gone through before, if I have a cross section of a pit here, pipe going in, pipe going out. So obviously at the top of it, I can have water coming in. So my inflow from on top is QG. My flow from upstream is QU. And my flow out is QO. Now QO is equal to QU plus QG. Water that comes in must go out. Yes, we can have some dead weight in here, but we're not going to account for that here. Okay, so pit 1. So pit 1 being the first pit. Alright, there's no pipes connecting to it. Effectively, we have a pit sitting like this, with a pipe coming out of it, the top of the pit here. So I only have QG and I have QO. So QU equals 0. QG, alright, going back through what we've looked at before, is 15.2 litres per second. Alright, because we don't have QU, therefore QG equals QO. What goes in has to run through. Now, if that is true, we have to work out our shock losses as well. We've got a K factor for our pits. Looking at this table here. So what I have case 1, I have my inlet pit with a outlet pipe. Looking at side entry pits, alright, it's given from the question. QG equals QO, I have a K of 10. It's quite a high K factor here for my shock loss. So K equals 10. That is given by table 6.9, and that's from our appendix. Really important to reference where you get values from. Alright, so this is my K. How do I work out my shock loss in my pit? HL is equal to KV squared on 2G. So what I need to do is calculate V. V, or velocity, is equal to Q on A. In this case, this is Q out. It's what's going out of my pipe, which is equal to QG, 15.2. Equals to 15.2, 10 to the negative 3, divided by pi D squared. D is 150 mil concrete pipe. Alright, just so we don't forget, D is 150 millimeters. This one here was given to us by the tutorial question. This is our assumption. Assume 150 mil concrete pipes. So chuck this into a calculator and you should get 0.86 meters per second. So my shock loss in my pit, or my losses in my pit, HL is equal to, like I said before, KV squared 2G, which is equal to 10 by 0.86 squared divided by 2 times 9.81, and that there should give you 0.377 meters. Alright, my max water level in my pit, this here is my HGL, or the starting HGL. Remember, we're taking into account a 300 mil freeboard. So what that's going to be is the top of the pit, subtract my freeboard, subtract my pipe diameter. Sorry. Yep, go away. 0.15. And that gives me 0.45, 99.55 meters. So that's where my hydraulic grade line starts. Now, this might be a bit confusing. It will make sense when we look at our cross section, which I'll draw in just a second. Let's just snooze this so it goes away. So my hydraulic grade line at my outlet. Remember, our hydraulic grade line is the level to which the water would rise if it wasn't encapsulated by a pipe. And with open channel flow, or with an open channel, open atmosphere, it's where the water level sits. So our hydraulic grade line at outlet is simply equal to our what we've just calculated. So our water level, 99.55, subtract my losses through the pit, 77 meters, and that gets me 99.17 meters. Alright, just so I can show that diagrammatically, we have a pit, we have a pipe, this is my top of the pit. This pit level here is an RL of 100. Remember, our hydraulic grade line starts somewhere. In this case here, this line is simply our maximum water level, 99.55. We have some kind of losses as the water comes in. So it drops and then it runs down. As long as this hydraulic grade line is higher than our pipe, it will run full. So this point here is what we've worked out. That's our 99.55, subtract our losses. So that's this number here, 99.17 meters. So this is our first diagram for pit 1. But what I need to work out is this will obviously connect to another pit somewhere down the line. So to work out, that will keep going into another pit, or to pit 2, that will keep going, and then so on and so forth. So I work out my RL. This hydraulic grade line will keep moving down, and then run flat, drop again, keep going. So I'm just working out all the levels in this pipe network. That's basically what we're going to be doing for this entire tutorial. Alright, same thing for your first assignment. So what I need to work out is the slope of the hydraulic grade line through here. So that's what's next. So what I'm going to do is I'll go my hydraulic grade line slope, SLO slope, SF. We have a formula for it, or what we can do to make our life easier is we have a chart in our appendix. So looking at our chart, alright, it's not the clearest one in the world, but what I have is I have my velocity running this way, I have pipe diameter running this way. So what have I worked out before? If I come back, my pipe diameter is a 150 pipe, my velocity is 0.86. So that's 0.6, that's 1, so 0.86 probably running somewhere through here. Pipe diameter runs this way, so 150. It's about here somewhere where it's going to meet, and then we come straight down and we can read straight off the chart. And so what we end up with is I end up with my slope from that chart is somewhere here. Alright, and that gives me a slope of 1 in this number. So this here is about 130. So my slope is equal to 1 in 130. Alright, so that's all good and well. I've worked out my slope, but now what I need to do is I need to work out my actual loss in my hydraulic grade line due to friction. And that's what we do with this slope. So my distance between pits is equal to, well, now I need to come back to my example and find it, or the actual question itself, which is somewhere in here. Where are we? Keep going. So from pit 1 to pit 2 is 100 meters. So 100 meters. So therefore my loss because of friction is equal to 100 on 130, which gives me 0.77 meters. Alright, so what that allows me to do is I know from this point here, if I cut my cross from here to here, 0.77 meters, I can now work out this point here. So my hydraulic grade line at my downstream pit, or pit 2, is equal to, well, what was that first number? This one here, which is my outlet. So 99.17 subtract 0.77, which equals 98.40 meters. So this number here is this number here, 98.40. All right, still here, and now I have another shock loss through here. All right, so pit 1 is done. We've worked out everything that we need to know. All right, now let's have a look at pit 2. Pit 2. All right, so my surface level is equal to, well, my pit 1 had my RL of 100. We've got obviously a slope in our channel. All right, if it's dead flat, no water's going to move. Our slope is 0.5%. So 0.5%. So we're subtracting 0.005, it's half a percent, times by the distance between the two pits, which is 100, which gives me the top of this pit surface level. So this level here is equal to 99 point something. Alright, obviously multiply these out, subtract it, should be 99.95. No, that'd be that one there. Meters. Yep, 99.5 meters. And then we start this same process all over again. Alright, so I know my hydraulic grade line at the inlet is that, so let's write that down. HGL at the inlet of my pipe. It's 98.40 meters. So my max pit water level is equal to, alright, so I need to go back through my freeboard levels. So that is going to be 98.40 subtract 0.3 subtract diameter of my pipe, and that there ends up giving me 99.05. Sorry. Max water level is from this one here. Alright, the top of the pit. And so that would give me 99.05 meters. That's my maximum pit water level. Now, looking at pit 2, I have QU, I have QG, and I have Q out. QU is equal to the Q out from here. QG is equal to the calculations from the example. Q out is them added together. So my upstream Q is equal to 15.2 liters per second. If I come back, alright, that's what we have over here. Now my QG is still the inlet capacity, alright, which is what we calculated through that example, which is still the same, so it's 15.2 liters per second. My Q out is equal to, add them two together, 30.4 liters per second. Now what I need to do, again, is work out my K. So my K for this case here, coming back to our appendix, this one, This time here I have an inlet pit on a through pipe, so I have obviously a pipe running the whole way through it. QU is equal to half a QO, and QG is equal to half QO. Because QU equals QG is 50% each, I have a K factor of 2.1. So K is 2.1. Alright, again, table 6.9, that's from the appendix. Okay, so now that we've got these, what I can work out now is my velocity is equal to Q out on A. Q out is this one, 30.4 10 to the negative 3 divided by pi. Remember, it's still a 150 pipe. This time I get a velocity of 1.72 meters per second. So my shock losses in that pit is K V squared on 2G, 2.1 times 1.72 squared, all divided by 2 by 9.81. And that there will give me 0.317 meters. So what I know is I've worked out this distance here, which is my 0.317 meters. So what I can do is go my hydraulic grade line at my outlet, is equal to my hydraulic grade line that went in, which is 98.40, subtract my losses, 98.40, subtract this one here, and that's going to give me 98.08 meters. Alright, so a bit of rounding, but that's okay. Again, we're going to work out my hydraulic grade line slope, SF, because this pit, or this pipe continues, keeps going, then we have pit 3 on the other end. So the slope here, alright, we come back to our chart, is this one down here. So still using 150 pipe. Now this time I have a 1.72 meter per second velocity, which is somewhere in here. So it's roughly around here somewhere. Alright, so somewhere, come down, and it's just over 30, probably just below 35. So to keep it cohesive with the solutions that we have, we're going to take this as 1 on 34. If you've taken 35, that's okay as well. So friction loss, or my hydraulic grade line drop due to friction, is equal to, now I need this here is my L, my length or my distance. Coming back to the example, where are we? I have 80 meters, so this time here, 80 on 34, which gives me 2.35 meters. So that is my loss, or my friction head loss. Alright, so now what I can calculate is my hydraulic grade line at my downstream pit, or pit 3, is simply equal to my hydraulic grade line at my outlet, subtract losses, so 98.08, subtract 2.35, all in meters, and it gives me 95.73 meters. Okay, so now what we do is we start the process again for pit 3. So we repeat this process again. So pit surface level, now what I'm looking at is equal to, depends on where you want to take it from. Alright, you can take it from the top of this pit, subtract the distance, or you can take it from pit 1, you get the same answer. So if I take it from pit 1, so I take my RL of 100. So this time here, I'm moving 100 meters, and then I'm moving 80 meters to this next pit. So subtract 180 times by my 0.5%, gets me that to a distance, converts to a meter. So the top of the pit here is 99.1 meters. So I know my hydraulic grade line at my inlet is this number here, is equal to 95.73 meters. My max pit water level is equal to the top of my pit, 99.1, subtract my freeboard level, subtract the 150 pipe, and that there is equal to 98.65. That's my max water level in the pit. Now, this pit 3, this is my pit. Obviously I have flow going out, a bit of flow going in, that's an O, and I have some flow from upstream. So my QG from upstream is 15.2 litres per second from the calcs. QU is equal to QO from pit 2, which is my QO, this one here, 30.4. Alright, and then that means my QO is simply equal to QU plus QG. So add them together. QO is equal to, what's that work out to be? 45.6 liters per second. Cool. Now, let's come back to our chart and have a look as to what these numbers are going to do. So back to our appendix from this table here. Inlet on a through pipe. Well, QU isn't 90%, QU isn't 50%. It's much closer to 70. If you run the numbers and work out the actual difference there, I think it's 67, 66.9, or it's about 67%. Alright, so we can round that up to 0.7. So I have a K factor of 1.3. So what I can do is go QU is approximately 70% of Q out. So therefore K is equal to 1.3, and that is from table 6.9, and that's from the appendix. Beautiful. Now let's work out my velocity. V is equal to Q out on A which is 45.6, 10 to the negative 3 to bring it to meters cubed, pi by 1.5 squared on 4 for the area, cross-sectional area of the pipe, and that V gives me 2.58 meters per second. So my loss in my pit, HL, is 2k V squared on 2G, chuck in the numbers, and what we end up with is 0.441 meters. So now we keep going through our numbers. Our hydraulic grade line at my outlet is equal to, where are we? My hydraulic grade line at my inlet. So this one here, subtract the losses. So that was 95.73, subtract 0.441, and that there gives me 95.29 meters. Keep going, we have our hydraulic grade line slope, which is SF. Alright, so what we're going to have, it's 2.58, this time here. Come back to our favorite appendix to read. So there's 2, there's 3, it's going to be somewhere in the middle. Alright, so it's roughly here for our 150 pipe. You can come straight down and it's somewhere in here. Alright, so it's probably 1 on 15, 1 on 16, 1 on 17. Any of them are going to be okay. So we'll take 1 on 16. Now the distance between these two pits, so pit 3 and pit 4, going back to our diagram, is 20 meters. We're working out the drop in this distance here between these two pits. So my friction loss is 20 on 16, and that's going to give me 1.25 meters, which means my hydraulic grade line at downstream inlet is simply equal to my outlet subtract my friction loss, 95.29 subtract 1.25, that gives me 94.04 meters. Now we'll put all of these information in a diagram, but this is our hydraulic grade line calcs for pits 1, 2, 3 and 4. So 4 we can kind of terminate here, we just worry about what's going in. Alright, but what we start to see is our hydraulic grade line drops fairly substantial. Alright, obviously our flow is going to keep increasing, we start dropping a lot more, where this here is obviously directly related to our slope factor. Our slope factor is directly related to our velocity. Our velocity is directly related to our area and flow. If I can't decrease my flow, I can increase my area. If I increase my area, I decrease my velocity. If I decrease my velocity, I decrease all of my losses. Alright, so all of these will drop down, which means I don't have such deep pits. This makes sense in our diagram in a minute. Alright, so from this we can work out our minimum sizing. So if I go pit 1, this is our minimum size. Minimum pit sizing. Let's just take pit 1 for our example. Our minimum size here is going to be equal to the top of the pit subtract, where did I put those calcs? my hydraulic grade line at my outlet. Alright, this is a bit all over the shop, that's okay. So my hydraulic grade line at my outlet, which is this one here, plus the thickness of my pipe, or the diameter of my pipe, 0.15. So that gives me my minimum pit size of 0.98 meters. This here assumes that the pipe is full. The only way the pipe can be full is if the hydraulic grade line sits above the pipe level. So that's what these calcs are doing. So we can go through and do this for all of them. So let's take pit 3, you can do pit 4 and pit 2. So let's look at pit 3. So my top of pit 3 is equal to 99.1. I'm then going to look at my hydraulic grade line at the outlet, subtract them from each other, and add in my pipe. So I had the top of the pit, subtract my hydraulic grade line at the outlet, which was 95.29 plus 0.15. Alright, this is going to give me 3.96 meters. And that again is assuming the pipe is full. Now what we can see is this is quite deep for pit 3, and pit 4 is going to be even more deep. And so we get a huge cost for constructing these, especially excavation. And so if we increase our pipe diameter, alright, say to a 225 or to a 300mm pipe, we will reduce the shock loss in here. We will reduce our hydraulic grade line slopes, so we won't need such deep pits. But I guess all of this information here that we've looked at, alright, so for all of our pits, the bottom line of it comes down to really trying to draw this diagram here. So let's go ahead and draw the diagram. What we're going to have is I have something like this. Yours will be with a ruler and nice and straight. I'll have my pit starting somewhere here. Let's try some different colors. Let's take this one here, so the blue. This is going to be my top of curb level, and that's at 0.5%. So as the road moves, as we look down the cross section of the road, the levels will drop. That's what we're expecting. Pit 1 sits here with my RL of 100, and it's going to come somewhere here. I'll have pit 2 somewhere here. I'll have pit 3 somewhere here, and pit 4 somewhere here. So 1, 2, 3, 4. So we went through this last week, how to do these drawings and what it's for. But we just do a quick refresher here. So I hope you guys do this properly. I'm gonna kind of skim through it. So we've got a mark here. This distance is 160 meters, going by our question. The spacing between these two pits was 100 meters. Between these two was 80 meters, and these two was 20 meters. Now, we worked out our hydraulic grade line. Let's do that in green. This is my hydraulic grade line. So if I look at pit 1, my max water level is here. So that is this point. So this point here is 99. 0.55. It then drops, and then it moves again. So that drop is this one here, this point at the outlet, which is 99.17. That will then fall across, and it reaches some point, and that point at pit 2, as we calculated before, was 98.4. So the point there is 98.4. It then drops to my hydraulic grade line at the outlet, which is this one, 98.08. And then it keeps going. So I see my hydraulic grade line. At pit 3, what happens? Looking at pit 3, that is this one here, or this one here, same thing. Alright, it's where it's reaching, and so this point here is 95.73. It then drops due to our shock loss, which we calculated, which is my hydraulic grader line at the outlet of pit 3, which is down here, 95.29, and we're meeting up at pit 4 at this level. So let's chuck these in. So that level there is 95.29. That then falls with our slope, and that will land at some mark here, which is 94.04. Now we know the hydraulic grade line will drop and continue, but this one here is unknown. So we write in here something like pipe continuation, I don't see spell it, that's okay, is unknown. Don't have enough data on what's upstream from there, but that's it there. So this is the gist of, I guess, what we're going to be looking at. Obviously you'll be drawing it to scale. So up on this side here, obviously we have our RL of 100 and so on and so forth. So you mark them out, draw it all to scale, and this is the crux of the design. So if we're going to do this, what we need to do is we need to have our pipes sitting below the hydraulic grade line. Alright, if they're not, they won't flow full. So if our hydraulic grade line drops below our pipe, it may end up half full. Alright, so this is how we tackle this tutorial. You need to do this as well in your assignment 1. Any questions, please send me an email or give me a call. Thank you.